Hello, welcome to LynxE. In this video, we are going to learn Norton's theorem. Now, if you see my board, already I have mentioned something. Okay, just ignore this and let's understand what is Norton's theorem is. Now, first thing, Norton theorem is nothing but exactly, I can say dual of Thevenins. So what you did in Thevenins, exactly, you just need to transform. You need to source transform your Thevenins. You come into the Norton's theorem. Anyways, what Norton's theorem stated? Norton's theorem stated that if you have a circuit and in this circuit you want to find current in the load resistor RL, let's say RL, we can replace this whole circuit by a current source which is nothing but named as IN or ISC. IN is nothing but Norton's current or a short circuit current. I'll explain why it is known as short circuit. Anyways, now for a Norton, this current is nothing but Norton current parallel with Norton resistance RN across RL. So hope you have understood this is nothing but Norton's equivalent circuit. Okay, so this will be my N. In this, you need to find current flowing in IL. So what would be IN? IL. So I need to find IL, which is nothing but current in RL. There is a parallel resistance RN and the total current is ISC. So by CDR, by current divider rule, what's my formula? Opposite resistor divided by RN plus RL into your total current ISC. Simple. Right? So this is nothing but my final formula. Anyways, what are the steps to find that? Let's start. So step number 1 is find short circuit current ISC or also named as IN. What does short circuit current means? So in this circuit, the first thing what you're going to do to find current, you need to short the RL. You're shorting the RL, that's why that resistor is named as short circuit current. So in this circuit, so here I shorted it and give a direction. Your wish, give it downwards or upwards. Anyways, for clockwise, I gave it downwards. So this will be my setup for finding ISC or IN, right? So use any analysis, use mesh analysis or use nodal analysis and find ISC. Okay. Once you're done with analysis, ISC, once you got ISC, the next step is finding RN. Now, purposely, I kept this step, which is a step of Thevenins. Why I kept? I'll tell you. RN is nothing but RTH. That is the work which you did in Thevenins for finding RTH, the same work you're going to do for finding RN. So let's replace the name. Now I say RTH is nothing but RN. Same thing, remove RL, replace source by internal resistance. That means voltage source will be short circuit, current source will be open circuit. In the same circuit, RL will remove, this is shorted. So this is nothing but finding RAB and RAB is nothing but RN. That's it. That was damn easy, right? So one step is common. The step number 2 is common in Norton's and in Thevenins. This gives me RN. Now your step number 3 is this. This is nothing but Norton's equivalent circuit. Norton's equivalent circuit, that's it. This is IL, right? Get your formula IL and that's it. We are done with Norton's equivalent circuit and we are done with Norton's theorem. So hope that was clear. Only step 1 is different and step number 3 with respect to the formula. Okay, when you compare it with Thevenins. Hope you are clear with the Norton's theorem. Thanks for watching my video. Thank you.
To know more, sign up to www.lynxe.in.